It seems as if good state management comes with some hidden fees. Those can be in the form of boilerplate, extensive code generation, or even unmaintainability. ChangeNotifier is just too simple, and there is a substantial amount of boilerplate when you move away from just simple counter apps. MobX has a lot of specifics and also code generation. And BLoC uses streams, which not everybody is comfortable with, and there's also quite a bit of boilerplate when you use BLoC. On the other hand, States Rebuilder is the simplest yet the most feature-packed state management package out there, and I really do not say it lightly. And as a bonus, there is literally just no boilerplate. Hello, welcome to Reso Coder, where you are getting prepared for real app development so that you will get freelance clients or a job and be confident about the apps you build. So subscribe and hit the bell to join us on our quest for becoming search after Flutter developers. As usual on this channel, we are going to go over this state management library by building a weather forecast app, where if you have watched my tutorials on weather forecast app for BLoC or for MobX, you know what we are gonna build. But if you haven't watched those tutorials, we're going to be able to input a city, search for it, and it's either going to give us some fake weather for that city in the form of some generated temperature, or it also can happen that we're gonna have an error which is going to display a snack bar at the bottom. As you can see, there is quite a bit to this app which is not really related to state management with States Rebuilder, so that's why I have a starter project prepared for you, which you can get from the link in the video description. And that starter project contains a pre-built weather search page. So the UI is already here. We just need to fill in some places which have to do comments. And then also we have a weather model, which simply holds city name and temperature in Celsius. And we also have a fake weather repository, which just generates some temperature and outputs a weather. And it also simulates a delay as if we were calling some remote data source on some server. So be sure to check out the written tutorial from the link in the description, where apart from this starter project, you can also find all of the code written in this video, links to the library, and overall go through this lesson at your own pace. Let's immediately start off by going into pubspec YAML, and we are going to add the States Rebuilder package to dependencies. States Rebuilder literally comes with just one dependency, and that is States Rebuilder, currently at the version 1.10.0, so be sure to use the same version if you want to follow along, although I am almost certain that there are not going to be any huge breaking changes down the line. So let's save this pubspec.yaml file and let's get right into it. We are going to create our weather store. The official docs are kind of vague in how you should name the classes. The naming conventions are really not there, and you will see why in just a bit. So because there are really no naming conventions for which class should hold state of the app, I decided that the best naming option is to name it weather store. So let's create a new folder under lib. Let's call it state. And inside of it, we're going to have a new file. Let's call it weatherstore.dart. Class weatherstore. This naming convention is actually borrowed from MobX. And notice that we are not extending anything. We are not going to use any annotations, any streams, any such things. All we are going to do here is just a pure Dart class. And because we have this weather repository here, we need to depend on it. So we are going to just create a final weather repository called weather repository, and it's gonna be private. So now let's create a constructor for this. And then all we need to have here is weather, which will be private. This is also a setter and a getter as a regular field. But we want to be able to only get the weather from outside of this class. So for example, from the UI, and that's why we are going to also create weather get only property, which will be public. And we are simply going to return underscore weather. And now we need to be also able to initialize getting of the weather from the repository. And this will be done with a regular method. So it will be just void get weather. It's going to accept the name of the city for which the weather should be gotten. So string city name. And we're simply going to make it async. And now let's just set the weather to be equal to await weather repository dot fetch weather, and pass in the city name, and that method fetch weather on the repository will simply generate some fake temperature. And you may say, Matt, where's the catch? How is this even going to work? Because we have just simple field, we have a getter, we have some method, but we are not even calling some notify listeners, as is the case with ChangeNotifier. And we definitely have to notify the observers in the UI whenever this weather field is updated, right? How are the UI widgets going to know when they should be rebuilt? And also, we do not have any loading field, for example, bool is loading. And you may be used to this because you always need to tell the UI that it should display a circular progress indicator whenever a new weather is being loaded, just like you can see here. So how are we going to show this progress indicator when we have just no way of telling the UI that something is loading in here? Well, this is the beauty of States Rebuilder. All of these things which are really not related much to our state, they are just something we need to handle with other state management solutions because they don't handle it for us. These things will be handled by State Rebuilder's reactive model, which is a wrapper class. And we're gonna get to this class in just a bit, and it's absolutely amazing because this allows us to write just pure Dart classes without any boilerplate, and we can literally test it as easily as just a regular Dart class because it really is just a regular class with no outside dependencies. Before we can use this store from the UI, we first need to inject it so that we can later on get it on other pages inside the UI. So let's hop over to main.dart. You may be used to providing some class down the widget tree using a provider package or just a regular inherited widget. Provider works by storing an instance of a class directly inside a widget, and then you can use Flutter's lookup up the widget tree to the ancestors to get a dependency which is provided with provider. However, States Rebuilder works in a different way, which is more similar to how Getit works. States Rebuilder utilizes the service locator pattern. The class which can inject dependencies with States Rebuilder is called injector, and it is a simple stateful widget which you put regularly into your widget tree, so injector. Let's import it from States Rebuilder, and it takes in an inject list, which is a list of injectables, and we are just going to inject something by saying inject, which is a class, and this class needs to take in a type parameter, and we are going to provide a method which will tell this injector which instance to instantiate for the injection. So we are simply going to say that we want to instantiate weather store, which we have just created. And weather store needs to take in a weather repository. And we are going to instantiate a fake weather repository over here. And additionally, of course, we need to also build the weather search page to be present in the widget tree. So we can do that from the builder parameter of the injector. So let's just quickly say builder, and it's gonna be an arrow function here, which will return weather search page, and it takes in a context which we do not really need here. Now, I told you that this injector does not use inherited widget to provide this weather store down the widget tree, but instead it uses service locator pattern. So whenever you will want to get weather store from some widget down the tree, you are not going to need to pass around the build context. But do not let this fool you, because the injector class is still a stateful widget. We can check it out. It's still stateful widget. And inside this pose, if we can find it, it's still going to unregister anything which was registered on it. So let me just find this pose. And there are a bunch of dispose keywords here. All right, here we go. Dispose. As you can see, immediately it calls unregister injected models. So in this sense, it works just like provider, which also basically unregisters, so to say, its registered dependencies. But it's still service locator, so keep that in mind. You do not need to pass around the build context everywhere. And be sure to check out the written tutorial for more information about this injector and what you can do with it. So now we have this injector in place. Let's just build the UI, which will use this weather store wrapped inside a reactive model, because that's the key class. Without reactive model, States Rebuilder would basically do nothing, because weather store is really just a regular class which is not capable of notifying the UI about anything. So let's hop into weather search page, and immediately we can see a comment that we should implement this with States Rebuilder. So we have build initial input method, which returns the city input field. Then we have a method which returns circular progress indicator. And lastly, we have something which returns the actual weather data. So let's hop over here, and we're going to start implementing this. You have multiple options in how to listen to changes in your stores. We're going to use the one which is most suitable for our use case here. And if you want to learn more, be sure to check out the written tutorial, which has links to the documentation and all of that. But here we are going to use a state builder widget. This takes in a generic parameter. We need to specify the type of store we want to observe by this state builder, so weather store. And this takes in a list of models. And this is what's crucial here. We need to provide our weather store not just by simply instantiating it. This would just not work at all. What we need to do is to wrap it inside a reactive model. And when you inject a class with an injector, just like we are doing in main.dart, this injector provides a handy method called injector.getAsReactive. This getAsReactive will grant us a reactive model wrapping T. And what should this T be? Well, we're going to specify it here. It should be weather store. So now this state builder will have an instance of reactive model which wraps the weather store. And this is what allows a dumb class like weather store, which doesn't really notify anything about nothing. This is what allows weather store to actually work for state management. All right. So now that we have these models specified, we currently have only one model, the reactive model. We also need to provide a builder. And of course, this is where the widgets will be built. Builder receives a context. We do not need that. But what we do need is the second parameter of builder, which is the reactive model. And with that, we can now implement the builder function and just build out different parts of the UI based on what? Because remember, we do not have any is loading field or error field over here. We just have the weather field. So how can we know if we've gotten an error from the repository or if we are just currently waiting for this future to be fulfilled? How can we do that? Well, we can use the powerful reactive model. Reactive model is what allows the weather store class not to be dependent on any external classes, and that is the class which observes and notifies us about everything going on in the store. That includes even the status of any sort of a future which is going on inside the store. So we can build out the UI by simply specifying an if statement, and if reactive model dot is waiting, well, we should display a loading indicator. So we are going to return build loading. Then we have another case where the reactive model already has data. So else if reactive model dot has data, and in that case we want to return build column with data. It's that simple. And how can we obtain the data held inside the reactive model? Because reactive model is not of our type weather store. It's a reactive model which wraps a weather store. Well, we can get to the wrapped class by saying state, and then we want to get the weather from it. And lastly, if we are not waiting nor we have data, this means that there is either an error in the model or the user has not even yet tapped any sort of a button. So we are basically in what is called an initial state immediately after the app is loaded for the first time. So in that case, we want to return build initial input. And you can always get this code from the written tutorial. This would work perfectly fine, and I leave it up to you to use this sort of a checking over the reactive model, but there is also a method on the reactive model called when connection state. And you can use that instead if you like exhaustive switches. And if you are watching my tutorials for a while, you just know that I love exhaustiveness, and you should love it too, because it prevents you from forgetting about checking for certain things, because if statements don't give you any guarantee that you have checked over everything that you need to check over. So instead of multiple return statements, we're going to have just one in the beginning. And now we can call reactive model dot when connection state. And now inside when connection state, we have a bunch of required parameters. So let's first handle on idle. And what should we do on idle? Well, we should build initial input. And of course, this should be a method. So let's do it like this. Then we have on waiting, which should return build loading. Then we have on data, which needs to accept a weather store instance. So what this means is that we are going to say store, which will be passed into our little function here. And we're going to output build column with data. And we are going to pass in store dot weather. Lastly, there is another callback. This is the last one on error. And whenever an error happens, we get an instance of error, which is of type dynamic. And we just want to ignore this error because we want to handle it differently. And we're going to do that in just a bit. But if you observe the UI for a while, whenever an error happens, we just display the initial input, just like this. And the only thing which is displayed in addition to that is this snack bar. And snack bar needs to be handled from a different place where we are going to get in just a bit. So let's just build initial input. It's nice that we are now building the UI whenever a state changes, but we actually need to make the state to change. That will be done from the absolute bottom of weather search page, where we have a nice to-do comment saying that we should get weather for the city. So let's do that right now. First, we of course want to get the reactive model. So final reactive model, which will be gotten from injector. And let's again call get as reactive, just like we are doing from the state builder. And we're gonna get an instance of weather store. And once we have this instance, we can now just call reactive model dot set state, which will grant us a function which passes us the current state of weather store. If we just take a look, the first parameter here is a function which accepts weather store. So this is the latest state which is currently present in there. So let's call it store. and we'll want to call store.getWeather and pass in the city name, which is passed into this method. This would be done. We are now initializing state change by calling getWeather, but what's important again is that we use the reactive model to do that. If we just get some random instance of weather store and call getWeather on it, just like this, of course we need to also provide an instance for the weather repository, but that's not important over here. If we just do something like this, no UI is gonna get notified ever. What's important is that we are calling getWeather on the weather store from within the setState function on the reactive model. Because again, reactive model is what hides all of the goodies of states rebuilder package. Without reactive model, there would be basically no states rebuilder as we are using it now. There is also another way you can use states rebuilder where you are notifying about the changes yourself, but that's for maybe another tutorial and I would not even use it because this reactive model stuff is much better than just notifying listeners yourself. But if you want to learn about it, there is a link to the official logs in the written tutorial. We are still missing one thing though, and that is showing the snack bar. And showing a snack bar is a side effect, so we cannot just show it here as we are building widgets, because the builder should really be reserved for building widgets and just not used for anything else. And there are multiple ways in how you can perform side effects with states rebuilder, but we are going to focus on the most useful one for us, which is literally just for handling errors, which is just what we want to do. To handle errors which are thrown from within the getWeather call, we can specify an onError callback inside setState directly. So onError, which will grant us an error and also a build context. So let's say context and also error. Error is of type dynamic, and if you have seen my error handling tutorial, and if you haven't, definitely check it out from the card in the corner, you know that we should not just blindly handle every single error that there is. That's because our weather repository, it can throw a network error. So this is the only known error which we want to expect in the UI. Any kind of an other error, we want to let it pass through and crash the app, because when you do not expect a certain error to happen, it's much better to just let it crash the app because you do not know about its severity. It may as well be unrecoverable error, in which case it's just better to crash the app. So to do that, we need to have an if statement here inside onError, and only if the error is of type network error, which is the only known error to us, only then we want to do something which is showing the snack bar, but otherwise we're going to throw error. So basically we are going to rethrow it and let it crash the app. To get the scaffold from down here in the widget tree, we're going to call scaffold.off, pass in the context, and then we want to show snack bar on the scaffold. And this takes in a snack bar instance. So let's just create it quickly. Snack bar, which holds content, and this is going to be text holding a message saying that we couldn't fetch weather. Is this device online? And I'm just going to copy and paste it from the written tutorial. All right. So this is what we are currently doing on the weather search page. We set the state of our weather store, all using the reactive model, because otherwise we are not going to get any notifications. And we also display a scaffold whenever an error callback is invoked. Let's just put a comma here so that it's nicely formatted. And then we also rebuild the UI by using reactive model when connection state and the state builder. So let's run the app and see how it works. And of course I get a bunch of errors because Flutter is behaving quite weirdly. We can see that once the app loads, we can enter a city name and we just got an error. and we can enter city name again, and now it loads. And just one more time, we want to see an error. All right, hopefully it's going to arrive sometime, and now it's here. So this app works, and we have really implemented it by just writing a pure Dart class, which does not have any boilerplate whatsoever. Its name is weather store, and then even the stuff which we wrote inside the UI layer, there is not really any boilerplate. There is literally even less boilerplate than you would have when you used BLoC or MobX or ChangeNotifier. There's just less of it. So it's really awesome how the state rebuilder package handles state management. And to go through this tutorial at your own pace once again, and to get all of the code, check out the written tutorial available from the link in the description. And if you are serious about becoming a great Flutter developer who can build real apps for clients or at a job, go to flutter.education, and link is also in the description, to get the top curated Flutter news and resources aimed at improving your app development career. Over there you can also subscribe to my mailing list to get the best Flutter resources delivered weekly right into your inbox. And if you do not want to miss more tutorials like this about state management and about deep Flutter topics, be sure to subscribe to this channel and also join the notification squad by hitting the bell button to make sure you grow your Flutter skills, because here on ResoCoder, I am determined to provide you with the best tutorials and resources so that you will become a search after Flutter developer. If this video helped you with understanding State Rebuilder, or maybe even if you have heard for the first time about this package, give this video a like and also share it with other developers who will surely benefit from this nice, simple and boilerplate-free state management too. If you like this package, really go on GitHub or on pub.dev and give it a like or a star on GitHub, because the author of this package really deserves some support. Leave a comment if you have anything to say, and see you in the next video.